Look at the weather.
It's beautiful here.
Non-stop rain.
Oh, man, it is a blazer out there.
It's cold and it's shivery.
It is cold.
Really coming down here.
I really enjoy your weather reports.
From the All Indiana Podcast Network, we're talking weather in a whole new way. From historical events to what's coming up, plus weather news, science, safety, fun facts, and more.
I like where this is going.
This is Weather Weekly. Weather Weekly with Wish TV Storm Track 8 meteorologist Marcus Bailey.
Episode number 33, Weather Weekly. Thanks for being with us here. I am meteorologist Marcus Bailey, Wish TV in Indianapolis. Good to have you along. This is the last podcast here for the month of September. Moving right along here and not feeling like it. We'll talk about the forecast here at the end of the podcast, but kind of a quick burst of summer here. Not unusual. I think our latest 80-degree temperature goes, 80-degree temperature goes well into October. So we can certainly linger on with the heat for a while here, but we are getting into that transitional period. Quick weather headline locally here. Man, we had a wet week last week. We had several rounds of rain, really came on that Monday and then again on Wednesday. And if I remember correctly from the Weather Service, they tweeted out that it was the sixth wettest 3-day stretch for the month of September in Indianapolis history. So, it was pretty active there with some of that rain. Didn't have any severe weather. We did have some flooding reports. Some of the numbers that we had come in officially from the Weather Service. This was, again, from September 20th to the 22nd. The hardest hit looks like... it was like south central Indiana. A lot of that came on Monday. Taylorsville down in Bartholomew County. That's kind of on the Johnson County, Bartholomew County line at about 5.5 inches. Columbus had about 5.25. Let's see, New Pal with 5 1/10, looks like. So we had several areas with over 5 inches. Seymour, about a little over 5.5 inches, actually just shy of 5 3/4 inches. Several areas with around 3 inches of rain. So yeah, look, and we were running pretty dry. So it did create some minor flooding issues, but it all receded. I do have some numbers. Johnson County, about 5 3/4. That's what I was looking for. I play golf often down around the Franklin area, and golf course down there reported 6 inches of rain. They actually had to close on Thursday because of all the rain. Greenwood picked up about 5 1/3. So it was a lot of rain over a short amount of time. And now we're kind of getting to a point now where we need to dry out. I mean, we needed that rain. I made a mention over the weekend that this is probably about as green as I've seen things this late in the game. Usually September is one of the drier months. With all the rain that we picked up last week, we now stand at the 23rd wettest September on record. So again, it's unusual. We usually average just shy, I believe, of 3 inches of rainfall for the entire month of September. So it's not one of the wetter months. As we start kind of getting into the cooler season here. So we're running on the soggy end, but we are getting to harvest season. So we do need some dry time. A lot of the farmers are going to be getting out in the field here over the coming weeks. It's been pretty good weather-wise. We've had a good kind of pace of decent amount of rain and then drying out at the right times. And we never got to a point where we were overly dry or overly saturated. So it ended up working out, I think, pretty well. Certainly not an expert when it comes to farming, but looked like it's been working out pretty well. And hopefully we'll have a good harvest season as we get here over the next couple of weeks. A couple of tropical headlines for you. It's getting pretty active in the Atlantic. We have Sam now, major hurricane, as of recording this on Monday, the 27th. Right now, the forecast track keeps it out to sea. There will likely be some pretty big swells in places like the Virgin Islands, Puerto Rico, Hispaniola, the Bahamas, Bermuda by late week. Some of those could reach the east coast of the United States, maybe even in Canada by the weekend. So that could cause rip currents, high surf, that kind of thing. But in terms of direct impact, as of now, it looks like the the storm Sam should stay at sea. We will see. That's a long way away. I think last check, it's moving northwest at around 9 miles per hour. So it's crawling, and a lot can change. May impact, kind of just clip Bermuda as it makes kind of a hard turn to the north. And sometimes you'll get these storms that will have an indirect impact for us here in central India. And obviously, if it's coming straight out from the eastern Atlantic, we usually will not get a direct impact in terms of wind or rain or anything like that. You usually need systems kind of feed through the Gulf. They go north and they'll feed into the Midwest. But these systems, if they get close enough to the continental United States, they get close to the eastern seaboard, they can kind of log jam weather patterns, which typically flow from west to east across the continental United States. And so if you get it close, it kind of log jams everything up. So, obviously this week we're benefiting from warm temperatures, quiet weather. If Sam gets a little bit close, we might continue that stretch because nothing can kind of progress eastward. So until something gets more powerful and kind of kicks it out, so we'll keep an eye on that. Again, I don't see a direct impact to the United States, but a lot can change. So we'll keep you updated on that. There are a lot of areas to watch from what I'm seeing now. There's a couple of disturbances just east of Bermuda, so it would be north of where Hurricane Sam is. 60% chance of tropical formation here through the midweek. Same thing with a couple of waves that are just off the coast of Africa. About a 50% chance of formation in the next 2 days. So we may see a few more storms that kind of get going. Remember, we still have a long way to go before hurricane season kind of wraps up. We're on the tail end, I would say, of peak season when you get into the end of September and October. But we're getting there. I mean, we were already, I think, through S or possibly, I think we already had T. So we're almost working our way through the alphabet there. So we'll keep an eye on that as things continue to develop. All right, wanted to take like a weird turn today. I found some interesting articles, maybe not directly Earth weather related, but saw an article kind of relating how different seasons change on different planets, and it just got me thinking about just other weather phenomena that happens on other planets. So I read some pretty neat studies from NASA and all that kind of stuff. So we're going to talk about that. That's coming up next here on Weather Weekly.
Audible's romance collection has something to satisfy every side of you. When it comes to what kind of romance you're into, you don't have to choose just one. Fancy a dalliance with a duke, or maybe a steamy billionaire. You could find a book boyfriend in the city and another one tearing it up on the hockey field. And if nothing on this earth satisfies, you can always find love in another realm. Discover modern rom-coms from authors like Lily Chu and Ali Hazelwood, the latest romantasy series from Sarah J. Maas and Rebecca Yarros, plus Regency favorites like Bridgerton and Outlander. And of course, all the really steamy stuff. Your first great love story is free when you sign up for a free 30-day trial at audible.com/Wondery. That's audible.com/Wondery.
All right, episode number 33 of Weather Weekly. This one's going to be kind of a fun one here. So, a little backstory before we kind of get into it here. And this won't be a really long one here because I am no astronomer, right? And yes, there's weather on other planets, but there's a lot of astronomy that kind of goes into all this stuff, and it's just not something I'm going to be diving into. And maybe we can get an expert on with us sometime and chat us up about some of this kind of stuff. But found some fun articles from NASA, so the official source, right? But my love for science, I think, first originated with just space in general. Loved space movies. I grew up adoring, in fact, and I still do, but some of the earliest memories of me watching movies was me watching Empire Strikes Back. I'm a big Star Wars nerd. I remember watching and loving anytime the news broke in for any of the shuttle launches. It was still a big deal. Obviously not as big a deal as when it was in the 60s, but, I firmly remember what was happening. I was very young, but I vividly remember the Challenger explosion. I remember sitting at my house with my mom. I don't think I was even in school yet. She had changed the channel. I was watching, I think, Sesame Street. She had changed the channel for me, and we watched it happen live. I had no idea what had happened. I thought it was just, some fancy pyrotechnic kind of thing. And my mom was very upset, and then I finally learned what unfortunately had happened with that. But again, so my love for science started with all things space. I wanted to be an astronaut until I realized that I'm petrified of being up high. So you got to get kind of over that if you're going to be an astronaut, right? Among other things. I'm definitely not that smart either, but that's kind of the first hurdle you need to get through. But that's where my love for science kind of came from. And so I found it fascinating. One of my favorite classes outside of any of my weather classes at Ball State, I had to take, I think, just for an elective, was astronomy. I took it as a night class. So it was like a 3-hour, once-a-week class, but they had a planetarium at Ball State. They still do. They have actually an exceptional one now. If you're up around the Muncie area, you should look at, I don't know how everything kind of works out with COVID and everything like that, but I've heard nothing but great things about the brand new beautiful planetarium that's attached to Cooper Science. There on that would be on that Riverside University, it's awesome. So check that out. Riverside. It is Riverside. Sorry. Anyway, I'm getting sidetracked, but I love the astronomy class because our professor would go to this website. I'm curious. I'm kind of thinking out loud here. I think it was called spaceweather.com. Yep, still exists. Very cool website. It's not exactly what you would think. It's not, thunderstorms and all this other stuff. But we would look at this every day. And I think why I enjoyed going to this website is I kind of related it to what Dr. Arnold would do in a lot of my meteorology classes, where we would begin many of our classes walking through a forecast for the day, whether it be for our area or for an area that might be dealing with some sort of significant weather. Well, our professor at the time, and I apologize, I don't remember his name. He wasn't a full-time prof. It was a night class, so I think he was kind of adjunct faculty there. He was great. I loved him. And he would begin every class going to spaceweather.com. And there was a few things that he would go through. The first one, like right on the left-hand side, it showed all of the sunspots and stuff like that. And then a lot of that would get through like these, minor geomagnetic storm watches and stuff. And we've heard about like the CMEs that can sometimes cause disruptions in electronic services that we will sometimes get. Those are all in there. You can look up at the auroral ovals where you may see the auroras or the northern lights. So, you could forecast that. And I remember also, I always found this fascinating. If you scroll to the bottom, if you're kind of following along and you're just bored, I always enjoyed looking at recent and upcoming Earth to asteroid encounters. So these are asteroids that were close to Earth that passed by. And I always found it fascinating that there would be like some that weren't that close because, just off the top of my head, I don't remember distance from Earth to Moon. 238,000, basically 239,000 miles. Okay. I rounded up 100 miles. I looked that up because it would have these names for all these asteroids that they have some sort of identifier, and it gives the date of either when it did or when it will, because it had some past, some future, pass by Earth, and then it gives the miss distance, how much it misses us by in lunar distance. Okay, and so. I think this puts this in such good perspective. And I know I work for a news organization, right? But let's face it, things can be very clickbaity, right? You often get a headline that may go worst case scenario, so you can click on it to actually read the article. I've seen that happen several times with near misses with asteroids. It'll be a near miss. Well, what it'll say is it's half the distance, it's a 0.5 lunar distance. Or maybe it's not even that close. Maybe it's like 2 lunar distances away, which may not seem that much, but you heard what I just said, right? The distance, one lunar distance, equals 239,000 miles. 239,000 miles. So, I'm just giving an example. It looks like on the 22nd, we had an asteroid pass by. I believe it says 30 meters. I think that's in meters. 30 meters in diameter. It was 15.2 lunar distances. All right. I'm not going to do the math for you, but that's a long way, right? When you compare it to space or even our solar system in general, it's not. It's close, right? But is a long way. The closest I can find that is coming up is September 28th. So this podcast will already been dropped, but I'm recording it. And that is 2.2 lunar distances away. Nope, I'm sorry. I just found another one. November 9th, 1.5 lunar distances away. So you might get some clickbaity headlines there that say, oh, got an asteroid coming up November 9th. It's a near miss. But whatever. But I also found this fascinating. You go to that website. It says on September 27th, 2021, there were 2,213 potentially hazardous asteroids. That sounds like a lot. But again, the sheer size of our solar system and how things just kind of revolve around and everything like that. Are there things that we've never seen before that are out there? You never know. Their definition, potentially hazardous asteroids, they use an acronym, PHA, are space rocks larger than approximately 100 meters that can come closer to Earth than 0.05 AU. None of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. So again, kind of, what we were talking about. So there may be lots and lots and lots of stuff out there. So anyway, kind of veering off from what I'm saying, but I don't have a lot to talk about. I just found a couple of fun articles from NASA, and some of these are geared towards kids, so the wording might be a little kid-friendly. Hey, that's fine. Maybe your kids will enjoy some of this. And then I also found another neat article that's got some fun facts that I'll just kind of read from you there, which is kind of in conjunction with NASA. So some fun facts about about some weather on other planets here. Let's start with Mercury. We're going to kind of go inside out here. Mercury, I think no shock here, right? Mercury, the closest planet to the sun. I think what's interesting, though, is just because it's close to the sun, you would think, yeah, it's sizzling hot all the time. But it actually has one of the largest extremes in terms of temperatures. One of the larger. I don't think it's the largest. Temperature extremes for the day, even though it is close to the sun. During the daytime, the sun would appear 3 times larger and more than 10 times brighter than it does here on Earth. And all of that sunlight then and the proximity of the sun, you can have temperatures as high as 800 degrees. But there's no atmosphere on Mercury, none. It's just a big rock is all it is. And so because of no atmosphere, nothing will trap in the heat. And so temperatures at night on the backside could get as low as 300 degrees below zero. So that's a huge extreme. So I think that was kind of shocking to me a little bit that, a planet that's so close to the sun can get so cold at night. always find this scenic. Venus is one of those planets that just fascinates me. And if you read articles about it and what we know about it, it's been called Earth's twin because of the distance it is from the sun, because of its size, because of its kind of makeup, but it is opposite. It is not in a habitable environment, okay? So NASA's right up on this. Because of the closeness of the sun to Mercury, you would think that would be kind of the hottest planet. It is not. Venus is covered by a thick atmosphere. Carbon dioxide and clouds made of sulfuric acid. Together, these act as a greenhouse, trapping heat and warming the planet. Venus can reach a scorching hot average temperature up to 847 degrees Fahrenheit. So, obviously, and we don't have a lot of information on Venus, but if Venus ever had any oceans, they dried up long ago when you have that kind of heat. Their evenings are obviously going to be much warmer as well. They'll cool down substantially, but Venus does have an atmosphere, so that allows for those temperatures to kind of get trapped in there. Mars, I think that's the one that we're always, movies have kind of, definitely, what's the right word here? It's the planet that people, and when you get into a lot of science fiction novels or movies or stuff that, if we ever had to colonize, we'd go to Mars. If there was any aliens, they're called Martians, right? So it's always been the fascination with the red planet, right? So Mars may be a little bit more habitable than any of the other planets in our solar system. It still wouldn't be great. Daytime temperatures, can be close to our winter temperatures on Earth, so you can get as warm as the freezing mark, 32. But Mars has a very thin atmosphere, so it can't hold on to the heat, so temperatures get to 200 below, right? So that is not something we could survive. That's notwithstanding the fact that there's no atmosphere, that you couldn't breathe, right? You'd have to have something manufactured, like a bubble or something like that, for somebody to live in there. Now, obviously, I'd say Mars is probably one of the more studied now, especially in recent times, that we've been able to put rovers on there a couple of times and stuff, and been able to get samples of the planet, that scientists have concluded that there was probably a good chance that there was water, and may have had a lot of water on Mars. And there may still be some there now, but it's not enough to feed the water cycle. You go back to your early elementary years, the water cycle is what we have here. You have oceans, it evaporates, and condensation, evaporation to condensation to precipitation, right? So that's what kind of keeps our planet going. There's not enough water to kind of get that going in Mars. It may be something scientifically that could happen, but there's just not a lot of water there, so it's mostly just a big red desert, okay? So that's Mars. Jupiter fascinates me. And it always fascinated me because of this, and it's the big red storm that's been there for many, 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 many years, okay? Now, obviously, no human would be able to experience this storm because it's a gaseous planet. There's no surface. The Great Red Spot is, it's been there ever since, we have, if you're listening and you've been alive, your entire lifetime, Jupiter has a red spot. Your parents, your grandparents, your great-grandparents, your great-great-grandparents, your great-great-great-great-grandparents, during their time, this was around. This big red spot. There are several other storms. You watch video. You can watch fascinating video of Jupiter and some of the Voyager videos that happened from the 80s and any other satellite missions that went out to take pictures. You can check out some really, really cool motion videos of this gaseous giant. It's awesome. But this red spot continues to kind of swirl around. I'm going to talk more about that. Actually, let me go over to this one article and another article that I read about Jupiter, which is kind of cool. And I'll tie in some other planets as well. So apparently, not only do you have this big, red, giant storm that looks like a hurricane, it also rains diamonds on Jupiter, possibly Saturn, Neptune, Uranus also experiencing these storms. So how does this happen? Lightning on the planets converts methane gas, which, these are all gaseous planets, turns them into carbon, and when that carbon hardens, it eventually takes on the form of diamonds. While Jupiter and Saturn have very hot core temperatures that can eventually melt the gems, diamonds tend to remain solid on planets with colder cores like Neptune and Uranus. So, if we can figure out, how to travel at the speed of light, I am immediately buying stock in companies that sell diamonds, because if that is true, and you have these, because obviously you couldn't go to Jupiter, you couldn't go to Saturn. You'd have to go to a Neptune or Uranus, which is way, 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 way out there. I'm talking in fantasy. This will never happen in my lifetime. Probably won't happen in my kid's lifetime, and it won't happen in their kid's lifetime. But let's just say it did. Buying stock in diamond companies, because there's a treasure trove. Can you imagine a planet that's untouched and uninhabitable, and it rains diamonds and they freeze? And you literally could just go and scoop it up, take it back. That kind of significantly ups the mining game a lot, does it not? So found that interesting. Do want to talk about this too. So I want to go back to Venus here. So Venus actually has basically what NASA describes it as is explosions in the atmosphere. They call them hot flow anomalies. All right. So according to NASA, they cause a temporary reversal of the solar wind that normally moves past the planet. So essentially, they create a giant space explosion. So these hot flow anomalies, as they're known, occur on many planets. They do include here on Earth. On Earth, these anomalies occur in the magnetosphere, which is way, way above the planet's surface. But Venus doesn't have a magnetic field and no magnetic sphere, so the HFAs occur much closer to the planet's surface. So the atmosphere on Venus is, we mentioned this, super thick. Spacecraft don't last more than a few hours on its surface before being crushed. So because of this, we don't know how these HFAs affect the planet, but NASA scientists have some ideas, and this comes directly from NASA.com. This is Glenn Collinson from NASA. At Earth, HFAs have a big effect, but don't necessarily rule the roost. But at Venus, since the HFA happens right up next to the planet, it is going to have a more dramatic effect on the system. Large space explosions occur close to the surface of Venus. But again, we've tried to land things close there, and it's just, we can't. So we don't know the effect on how it affects the planet. We can only assume from what we know, and it's basically hellacious at the surface of Venus. For being a solid planet and not too far away from the sun, that you would think could have similar weather to us, it is completely the opposite and would not be a good place to be. All right, let's move on. Let's see here. So more on the storm on Jupiter. So this bad boy here, the red spot's been going on for 400 years. 400 years, right? The Great Red, okay, so this article here, it's been 300 years in counting. It's almost 400 years now. Anticyclonic in nature. So what do we mean by anticyclonic is hurricanes are cyclones, okay? Areas of low pressure are cyclones. We actually call area of high pressure on Earth anticyclones. Basically, the reason and the difference for all of them, and there's some other things that go in, but basically, cyclones, the wind flow and the wind pattern moves inward and counterclockwise. In an anticyclone, the wind pattern moves outward and clockwise. Okay? So here's the interesting thing. It's anticyclonic and has tornadoes. And it was once more than 2 times the size of Earth. It does appear that it's gotten smaller and smaller over time, but it's a long ways from being completely done. It swirls counterclockwise, even though it is anticyclonic. And its speeds are up to 300 miles per hour. Something that's interesting, and obviously, because it's a gaseous planet, there's only so much that scientists can do with the technology that we have. This actually is a very hot storm as well, because it's so massive. It generates its heat somewhere up to 2,400 degrees Fahrenheit. This was just newly discovered, but I found that kind of fascinating that it basically generates its own heat from itself spinning and stuff like that. So fascinating stuff there. Let me go back to Venus here. Sorry, I'm kind of going back and forth, but I don't want to get too ahead of myself, and I want to try to tie some of these together here. Another article that came from NASA that there's snow on Venus that's made of metal. So I think this is interesting here, and this is where science is just weird. And science is, you think forecasting weather on Earth is tough, right? So the landscape of Venus, it can get almost, I mentioned this, it gets almost to 900 degrees, right? It was like, what did I say, 847 or something like that, and completely dry. It's a barren wasteland. It's like a desert. But it snows. So how does that happen? So what NASA suspects is that you have the molten, the hot temperatures of Venus's lowlands, vaporizes essentially pyrite materials, and it turns them into like this space metal mist that will then kind of just fly around into the atmosphere. And then it'll just fall over the mountains where it's going to be naturally cooler, and it gets coated with this shiny metal substance, essentially. So that'd be kind of an interesting, weird view, right? So we mentioned the temperatures on the extremes on Mars. So this one just reiterated. It said dramatic temperatures increases and decreases can get crazy on Mars, especially true where a temperate 70-degree Fahrenheit day will quickly turn to a minus 100-degree night. Such a drastic shift gives way to a 100% rate of humidity that lasts until the night's frost dissipates. So, again, pretty severe extreme. Let me see what else we have. I think I just did the spot. Oh, Saturn. Okay, so Saturn. So you are 900 million miles away from the sun when you reach the ringed planet. That's actually that's almost twice as far out as Jupiter. So that distance comes with a freezing average temperature of about minus 285 degrees Fahrenheit. So that's average, right? So that means like the overnight lows are going to get colder. Your highs are obviously going to be a little bit warmer than that, but your lows are going to be actually a bit colder than that. Some of the moons are actually a little bit more fascinating than Saturn. Saturn is, again, another gaseous giant, doesn't have quite as much activity that Jupiter has. But there are some familiar weather patterns on some of the moons, especially Titan. So scientists believe that Titan experiences seasons, has clouds, it rains. There's an atmosphere that is made largely of nitrogen, like ours. But rather than the water cycle, what scientists believe Titan cycles a chemical called methane, and the rain that falls from the clouds is methane, and it falls into lakes, rivers, and seas of methane. And obviously, Titan would be far too cold for any human to visit. But it's probably, and I think a lot of articles came out back in the 90s about that one of Saturn's moons, and it was Titan, may more closely relate to Earth, but it is just so far away from the sun that it's not something that would be something that you could research for normal humans to send there. And again, it's 900 million miles away. We just don't have that kind of speed to get out there. So, all right, let's go to Uranus. No jokes. Sorry. It's an ice giant. Its temperature is about minus 360. It also, this is what I find fascinating here. So, and this was what kind of got the whole thing started with this podcast. So it was comparing seasons, right? And the whole reason why we have seasons here on Earth is because of the tilt of the Earth's axis, which is like a 23.3, I think, or something like that. So the Earth tilts, and with the rotation around the sun, you get 4 distinct seasons, right? And because the direct sunlight will vary depending on the tilt of the Earth, and that's what dictates the seasons. Obviously, we're now getting ready. We're right in the early parts of fall. We're coming out of summer. So our day and nights are almost equal, but we're trending more toward more nighttime and less daytime. So, there are a few other planets that have similar tilts to us, so they experience, distinct seasons. Jupiter has no tilt or very little tilt, so there is no change in seasons. I believe Venus was one of those that actually has a similar tilt to ours, but because they are outside of us, it is double the time that it takes for Venus to go through seasons as it would be compared to us. Okay? So, Uranus is on a 98-degree tilt. So that basically means that the poles are aiming directly at the sun. So what's interesting about that is that what scientists believe is thousands or maybe millions of years ago, that Uranus was actually knocked off its axis by a large object, maybe an asteroid or a meteor or a comet, and that's where it stands right now. So Uranus is so far away from the sun, it takes 84 years to make a single orbit around the sun. 84 Earth years, okay? So each of their seasons is 21 Earth years long. So the tilt causes some unusual seasonal changes as it orbits the sun. In summer and winter, large parts of the planet see nothing but daytime or nighttime for the whole season. That's 21 years. In spring and fall, Uranus goes through a full day-to-night cycle every 17 hours. Uranus sometimes has huge storms, and these unusual seasonal cycles may play a part in them. So I thought that was kind of fascinating. What else do we have here? Neptune. Also way out there. An average of 2.8 billion miles from the sun means the ice giant is super cold. Average temperature of Neptune is minus 360 degrees Fahrenheit. What's interesting is it's actually a little bit farther out than Uranus, but they have the same temperature, even though there's extreme differences from the distance of the sun. Scientists don't know why. Neptune has a thick atmosphere. It is covered by constantly changing clouds that whip around the planet. Wind is basically the big feature on Neptune. Wind speeds there have been measured at nearly 1,200 miles per hour. Those are the fastest in the solar system. I thought that was fascinating. I think it's amazing that we actually know that too, right? I think it's amazing that we know that kind of information about that. A couple of other things. This isn't necessarily weather related, but we'll wrap things up here. Io, another moon, one of Jupiter's moons, has active volcanoes everywhere. So Io, which was once thought to be frozen, dormant planet, but once we had a satellite kind of roll through, showed that it is indeed not, and it has volcanoes everywhere. It can spew lava up to 250 miles in the air. So, interesting what you find out when you can get satellites nearby, which again takes many years to get out there. Last thing here, Saturn. I always find Saturn's one of my favorite planets. Just a pretty planet with the rings and everything like that. So I think this is cool. Saturn storms can crank out 10 volts of lightning per second. So this is the words of the article here. Imagine if it suddenly started raining everywhere on Earth, and that rain brought with it ferocious volts of lightning that shot out 10 times per second. So on Saturn, they call it the Great White Spot, and it happens every couple of decades. Witnessing a superstorm encapsulate an entire planet can be pretty terrifying, but what scientists are most intrigued by is the fact that this storm could be proof of water on Saturn. The proof isn't in the storm itself, but rather in the fact that a storm that massive could be over so quickly. On a planet void of water, that same storm would likely last a century or more. So, kind of cool. But I'm just trying to, kind of envision those kind of lightning bolts, 10 volts per second, just crazy electrical. So just some fascinating things to kind of look up, and you can check up all that stuff. Again, go check out, if you're interested in that kind of stuff, go to spaceweather.com and you can check that out. And that updates daily. There's also some actual NASA, that's not a NASA. That's not a NASA thing, but NASA does have its own space weather kind of thing. Basically, they forecast a lot of the CMEs that will be ejected from the sun that can impact a lot of our satellites and electronic devices and stuff like that. But if something you're interested in, Google search that as well. There's a lot of cool information on that as well. All right, we'll have your forecast as we wrap up the month of September and we look ahead to the first days of October. That's coming up next here on Weather Weekly. All right, here's a look at your forecast as we're wrapping up the month of September. October will begin at the end of this week. Certainly not feeling like it. I'll tell you what, pretty nice weather pattern here shaking out over the next 8 to 10 days. We've had a few days already in the 80s to open up the week. I think that trend will continue through Thursday. I think you're going to have a lot of sunshine, so no major concerns here. I think you get maybe slightly cooler temperatures as we head into the end of the week, Friday specifically, and into the weekend. But still around average. When you start off October, you're usually into the low and mid 70s. We should be right there. There is a slight chance for rain with a cold front moving through on Saturday. Maybe another chance for some scattered showers on Monday, but numbers should stay into the low, if not mid 70s here through the weekend and early in the work week next week. 6 to 10 day outlook for temperatures above average. Pretty good chance for that. And a slight chance for above average precipitation. The 8 to 14 day outlook also above average temperatures. This actually calls for below average precipitation. That will take you into that kind of second week of October, and the October outlook still as we go into this new month. No major changes. The monthly temperature outlook from the Climate Prediction Center calling for above average temperatures and for at least the northern third of the state with above average precipitation. So here we go. October is upon us. We're going to start getting those cooler temperatures. The days get shorter. That means the leaves are going to start changing here. Fall foliage will start peaking here through the middle portions of the month. And of course, we get a whole host of different weather once we approach Halloween. I think last year was a little bit on the chilly side. I remember a couple of years ago it was raining. Actually, a couple of years ago, I believe it was snowing and it was cold. I think I remember my kids crying because they wanted to be done. They were, those Halloween costumes, they don't really offer much protection. So from the chill. So I've been through Halloweens with my kids in the past probably 5 years. One was super hot. So you can get a little bit of everything. That will be next week's podcast, a preview on what's ahead for the month of October. Thank you for listening. We always appreciate your time. We always appreciate your feedback. You can reach out anytime, questions, comments, concerns. If there's a subject matter that you'd like to hear on Weather Weekly, love to hear it. You can email me anytime, marcus.bailey@wishtv.com. You can also reach me on social media. Marcus Bailey Weather is what you search for on social media, on Facebook rather, and at Marcus Bailey for Twitter and Instagram. You can follow me there as well. Appreciate your time. And while you're here, make sure you check out all the other great podcasts on the All Indiana Podcast Network. We'll talk to you next week.
Discover more from Storm Track 8 Weather and Wish TV. Online at wishtv.com and when you follow Wish TV on Facebook. Plus, be sure to check out more great podcasts from the All Indiana Podcast Network now at allindianapodcastnetwork.com.